So you're basically telling me they found this rare wandering black hole event using AI? We're doomed, folks. We're doomed. Hey, folks, welcome to The Deep Cosmos. I am your host, Devin J. Barrows, and this is the second episode in a new series called Astro News, where I look at the top headlines in astronomy, ranging from planetary science all the way out to black holes at the centers of galaxies. You name it in astronomy, we are going to cover it. If you want to stay up to date with any astronomy news, please subscribe to this channel. Give this video a like so we can spread the word and keep everyone up to date with our place in the universe. So, without further ado, let's get into the Astro News. All right, so the first headline that I wanted to go over came from Rutgers University, and the title of the article is A Rutgers Scientist Says Shallow Water on Jupiter's Icy Moon May Not Offer a Direct Window into Its Deep Surface. When we refer to Jupiter's icy moon, we are talking about Europa. This moon has been at the pinnacle of astronomers who are looking for the search of life. Not looking for the search of life, they're looking for life out there, and Europa is a very good candidate because we realize from other observations of this moon that it has an ice shell, and underneath this ice shell there is thought to be this ocean. An ocean of liquid water. And this is maintained because Jupiter is this massive Goliath planet. And as Europa's orbiting Jupiter, there's a lot of tidal disruptions that happen on the planet because Jupiter's gravity is so strong. So it's almost like sloshing the water around inside Europa. And this could be a gateway to what we think may be a chance of life on the moon. This would be the first discovery of extraterrestrial life, and it's on a moon of Jupiter. It's insane. So there are actually a couple missions heading out to Europa currently that are going to look at Europa's surface and try and find a way to connect to its ocean deep beneath its surface and hopefully go from there. This kind of comes with some bad news from this Rutgers scientist by the name of Lujendra Oha, or Oja. I probably totally butchered that name, so I apologize, but he is the main scientist, planetary scientist that was looking into this. And his main thing is that we saw in past observations that there are shallow water traces on the surface of Europa. And it was thought initially that the water on the surface of Europa could be from what's called cryovolcanism. This is when the water from beneath the surface shoots up to the top and splurges water across the surface of, in this case, Europa. And this water would be a gateway to connect to the deep ocean because it's from the inner part of Europa. However, what this scientist is saying, Mr. Oja, is saying is that from what he can tell, the shallow water that's on the surface is not from the deep ocean. In fact, it is just from turbulence that is caused on the ice shell surface. So what that means is that, from these shallow waterbeds that we are observing, they would just be from the fact that the ice shell of Europa is going through some melting phases and it's leaving shallow water imprints. Now, this is still a pretty cool concept, but the problem is that this water that's only from the ice shell itself is not connected to the deep ocean that could have a possibility of life, or just a possibility of learning more about this kind of moon's system and how it's there in the first place. But if this shallow water on the surface is not connected to the deep ocean on Europa, we can't tell. And this is just what they're saying. The scientists here are saying there's an icy shell, there's water underneath, and there's all this speculation about how that water can come from deep underground and make its way all the way up without freezing en route. And from his research, they're saying that's really what we think we disproved. The fact that the water came from the deep ocean. Their main conclusion highlighted in the article here is that the route from deep ocean to shallow ice is probably much more difficult than scientists have assumed. Not good. There are two missions currently heading to Europa. There's NASA's Europa Clipper mission that was launched in October of 2024 and will arrive to Europa around April 2030. And then there's the European Space Agency's Jupiter Icy Moons Explorer mission, known as JUICE. I love JUICE on Earth, so it's a great name. This was launched in April 2023 and should arrive in July 2031. So this is kind of sad in the fact that we may not get a more clear image from the shallow water on the surface of Europa to connect it to the deep ocean. But this is really good in the sense that we get a more accurate description as to what we see on Europa. So if we go there and explore with these missions, we have a better picture. And with that better picture, we'll get better and more refined results that we actually want. Sometimes in science, you may look for like a really cool, like, oh yeah, like a connection to the deep ocean that could have life in it, and you jump to these crazy conclusions. But in reality, you have to look deep in the evidence and actually get data that you can analyze, and get a good result for. And know that even though the result is not as exciting, it's right. The simulations that they did, it ran through how these shallow bits of water on the surface came. So they ran through a bunch of simulations and came to those conclusions. That's how they did this research. Okay, that was the first one. The next headline I wanted to go over comes from the University of North Carolina's Chapel Hill Observatory. And the title for this article is UNC Chapel Hill astronomers identify one of the universe's rarest black hole events. Now, if you know me, I love black holes. They're my favorite celestial object to think about, to study. And I eventually want to do research with black holes as an astrophysicist. So this headline, I read this and I was like, wow, this is, amazing. Let's look into it. The more I read this article, the more this article interested me. I'll read the first line here. So it says, a team of astronomers at University of North Carolina at Chapel Hill has observed an extremely rare wandering black hole located tens of thousands of light years from the center of its galaxy. For some context, usually black holes, the supermassive black holes, these are black holes that are millions of times the mass of our sun. They reside at the centers of galaxies. So they are responsible for accretion sometimes, which is like them essentially taking in gas and dust. And if we can learn more about these supermassive black holes, we can learn a lot more about the environment of these galaxies. In this case, however, the massive black hole is not at the center of a galaxy. It's wandering away. So hence the term wandering black hole that they're saying. These kinds of events are pretty rare, and this article says occurring on average once every 100,000 years. Cosmologically speaking, the universe is 13.8 billion years old, so this is relatively short in terms of the universe, but this is literally half of human history. Humans have been on Earth for around 200,000 years or so. That's half of our history, folks. So that's pretty rare. This name of this is called a tidal disruption event. And they wouldn't have discovered this wandering black hole because, hence the name, black holes are dark. The only way we can see black holes is if they're absorbing something that emits light. And also for some other context for those who aren't into black holes, they are essentially an infinite well, an infinitely small singularity that's super dense and has immense gravity, but they're dark. So if a black hole is eating something or accreting mass, it usually is from a donor star or from some gas that's hot and near it. So when the black hole is doing this, we can see the light from that accretion process or eating process, and we can see the black hole. We can see the shadow where the center is. So that's how we really get this. In this wandering black hole, which is named TDE 2025 ABCR, this one was wandering, and then a star happened to be in its proximity. And then as this wandering black hole came near the star, it just shred the star apart. And this obviously gave a burst of energy, and it started to kind of accrete the mass from that star. So this is something that, again, is extremely rare, but once that happened and our telescopes detected it, we knew that was a black hole based off of other observations. The article says researchers found the flare approximately 30,000 light years from the center of a massive nearby galaxy, the farthest offset ever observed for an optically discovered tidal disruption event. Wow. 30,000 light years. That means that if I shine a light beam from the center of that galaxy to where that black hole was, it would take 30,000 years for the light to reach that. That is the fastest thing in the universe, which is around 670 million miles per hour, some crazy number. That takes 30,000 years to get to its destination. Insane. So very far away from where it should be. Usually, like I said, almost every tidal disruption event we've ever observed has occurred at the center of a galaxy. This one is not even close to the center. The black hole responsible is estimated to be roughly 1 million times the mass of our sun, which is insane. And researchers believe it may have been left behind after two galaxies merged in the distant past, which makes sense. Or possibly thrown outward through gravitational interactions with other black holes near the galaxy's center. So this means that this massive black hole was at the center of a galaxy. There was a galactic collision, the two galaxies colliding together, and this black hole got launched out from this collision. A supermassive black hole being launched away from its host galaxy. Insane. The other thing that caught my eye, unfortunately, was that the discovery was made possible in part by artificial intelligence. So you're telling me that this wandering black hole, this rare astronomical event, was discovered in part by AI. It says here, researchers used an AI classification tool called TDE score, developed by Robert Stein, to scan enormous amounts of telescope data and identify promising TDE candidates. Here's my thing on AI. AI, in terms of doing scientific research, can do a lot of the less important tasks very fast and efficiently. So in terms of scientific research, it can be a good thing. What I am not on the side of is using it right now, because the way that we cool data centers is using a lot of fresh water. In fact, tens of thousands of gallons of fresh water to cool down these massive data centers. And it's taking away ecosystems. It is harming our planet and actually causing more climate change in that sense as well. Because of that, I cannot be supporting AI. I don't. If we find a better way a more efficient way and a more Earth-friendly way to cool down these data centers and use AI, so be it. But as of right now, it's destroying the planet. And this is the only planet that we know that can inhabit our life. So the more we do this planet to harm it, to take down nature, and to not preserve it, the less better we are off as a species. A lot of scientists have been more open to AI. Even someone as big as Neil deGrasse Tyson, he was openly talking about AI and its uses and not really batting an eye about it on Star Talk. And other scientists are using AI, like in this article, to do research. I'm still against it. I think that it's helping research, but I would have to see more improvements in how we maintain it. On a side note, generative AI, no. Even if we find a way to better cool data centers and it's more efficient and more environment friendly, generative AI is taking away artists' credit and it shouldn't be used. It's a whole other discussion for a whole different day. But for the sake of science, if we're going to use AI, we have to find a way to preserve our planet. And as scientists, I think we'd be more smart about our conservation of us on Earth first, over using AI for some convenience that we could eventually do, as of right now. So if we cannot find a sufficient way to maintain AI without destroying our planet, we shouldn't be using it. That's my opinion, and I stand by that. The other article, the last one I kind of want to go over here, is from Caltech. And the title of this article is Neptune's Inner Moons May Be Shattered Remains of Ancient Icy Worlds. This is pretty cool. So, long story short, you have, the fact that Neptune is this mysterious icy world out there, a lot of people's favorite planet. I call it the Mystic Guardian because it's the outermost planet and it is closest to the Kuiper Belt. It's it's a cool kind of balancing double-edged sword. The consequence of this position is that sometimes Kuiper Belt objects can be just close enough to be influenced by Neptune's gravity, come in and disrupt Neptune's system and also just our system, the solar system. So it is thought that a long time ago, Neptune's moon Triton was intercepted. It wasn't originally orbiting Neptune. And once the arrival of the moon Triton came and started to orbit Neptune, it ripped Neptune's original moon system apart. So now we have some rings that are around Neptune, and we have some moons, but they're all kind of discarded and dismembered because of the arrival of Triton. So that's kind of the thing here. And we couldn't really do much research on these systems because we didn't really have the technology to look into Neptune's rings. Yes, Neptune has rings also. If you didn't know, Neptune has very dark infrared rings. They exist. And we didn't really have the technology to look into this. Enter the James Webb Space Telescope, the best telescope there is, right? One of the best. And this telescope now will help us actually examine the data and look into these moon systems. So what they found was that the inner satellites that are very close to Neptune, or moons really, were most likely caused by Triton coming in and ripping them apart. And this is new in terms of the fact that now with this analysis we can be closer to confirming that Triton caused this. And when they looked into these moons, they found these things called phyllosilicates. And I don't know what they are, but they're important, and you'll see why. They say here in the article, phyllosilicates had never been detected anywhere in the outer solar system beyond Jupiter, so that was not on our list of things to look for. They also say we were shocked to find the observed clays, which had to come from objects that were much, much bigger than Neptune's small inner ring moons. Interesting. This would mean that the moons on Neptune, originally, before Triton came in, must have been bigger, and they must have had something in their surface that had phyllosilicates in it. Okay, Another interesting result is that signatures of magnesium-rich phyllosilicates were found in the spectra of Larissa, Galeta, and the rings. Larissa and Galeta are the moons that are close to Neptune. Minerals that only form in the presence of liquid water. Okay, interesting. And yet, no water ice is indicated by the spectra of any of the 3 moons studied or their rings. What? So they're saying that this mineral they found could only be present if liquid water was once there, but there's no evidence of water ice that they found in any of the spectral analysis. What? So we don't know what's going on here. This image that they're showing is a really good diagram of what's going on. Or what happened. So Neptune once had a system of large moons. Then you have Triton arriving into the system. Then you have the destruction exposing material from deep inside these ancient moons, like shown here. And finally, you have the small fraction reaccreted into today's small inner moons and rings, carrying fingerprints of those ancient interiors. So we are essentially seeing the interiors of old Neptune moons that used to be there. They were so battle-scarred by Triton coming into Neptune's orbit that they were shredded apart and their guts are now shown orbiting Neptune. We are seeing moon guts, folks. The James Webb Space Telescope is a savior. It has really gotten us very far in these endeavors in research. So kudos to James Webb. Another thing I want to note here is that there is a new unidentified hydrated mineral in this observation that we've never categorized before, ever, so it's a brand new thing. And in general, the phyllosilicates I mentioned earlier only can exist from a heated central source, just to make it more clear that it could be from a moon system that was there before Triton got intercepted. Really, really, really cool research. So with that being said, that's pretty much all the headlines I wanted to go over. We'll be back next week with some new astronomy headlines to keep you all up to date. Like I said before, please subscribe to this channel if you want to be up to date with all things astronomy and our place in the universe. Leave a comment about what you want to see next in other headlines. But other than that, think deep, folks. I will see you next time.